Hi, I'm Joseph from IG2102, and in today's video I will answer all the activities here in chapter 5 entitled Ethernet. By the way, Ethernet is now the predominant LAN technology in the world, and Ethernet operates in the data link layer and the physical layer. The Ethernet protocol standards define many aspects of network communication, including frame format, frame size, timing, and encoding. When messages are sent between hosts on Ethernet network, the host format the messages into the frame layout that is specified by the standards. So all in all, this chapter examines the characteristics and operation of Ethernet as it has evolved from a shared media contention-based data communications technology to today's high bandwidth full-to-text technology. Chapter 5 has 5 sections, and Section 5.0 Introduction, Section 5.1 Ethernet Protocol, Section 5.2 LAN Switches, Section 5.3 Address Resolution Protocol, and the last one is the Section 5.4 is the summary. So let's get started answering the activities. First in the Section 5.1, here in the page 5.1.1.5. So let's get started. So activity MAC and LLC sublayers. So instruction description of the MAC and LLC sublayers are provided in the table. Click in the MAC or LLC fields to match the descriptions to the correct sublayer. Hacker characteristics here are in the MAC LLC. So let's choose from MAC and LLC. So let's start. So controls the network interface card through software drivers. So it's LLC. Works with the upper layer to add application information for delivery of data to higher level protocols. So it's LLC again. So works with hardware to support bandwidth requirements and checks errors in the bits sent and received. Controls access to the media through signaling and physical media standards requirements. Supports Ethernet technology by using CSMA/CD or CSMA/CA. So it's remains relatively independent of physical equipment. So it's LLC. So let's check it. So yeah, it's all correct. So let's proceed to the next activity. And page 5.1.1.6. So activity identify Ethernet frame field name. So instructions drag the 802.3 Ethernet frame field name to its description. So these are the frame and these are the fields. So description. So 802.2 header and data. So it uses pad to increase this frame field to at least 64 bytes. So describe which higher layer protocol has been used. So it's type. The frames originating NIC or interface MAC address. So it's source address. Assist a host in determining in the frame received is address to it. Notifies destinations to get ready for a new frame. Synchronizes sending and receiving devices for frame delivery. So detects errors in the Ethernet frame. So let's check it. So it's all correct. Field 802.2 header data uses pad to increase this frame field to at least 64 bytes. Type describes which higher layer protocol has been used. Source the frames originating NIC or interface MAC address. Destination address assists a host in determining if the frame received is addressed to it. Preamble notifies destinations to get ready for a new frame. Start of frame delimiter synchronizes sending and receiving devices for frame delivery. Frame check sequence detects errors in the Ethernet frame. Let's proceed to the next figure. So activity identify Ethernet frame field name. So instruction drag the Ethernet frame field name to its correct location on the diagram. So let's put this to the correct location, and 7 bytes is frame. No, 1 byte start. 6 bytes is destination address, and 6 bytes is source address. 2 bytes is length. 46 to 1500 bytes is 802, and 4 bytes is, oh wait, 4 bytes is here and variable is here. Check it. So yeah, it's all correct. So let's now proceed to the next activity, where you can find it in 5.2.2.4 or 0.2.2.4. So activity frame forwarding methods. Instruction description of switch frame forwarding methods are provided in the table. Click in the store and forward or cut through fields to match the methods to description. So these are the descriptions. So store and forward or cut through, these are the verses. Buffer frames until the full frame has been received by switch. Store and forward. So checks the frame for errors before releasing it out of its switch ports. If the full frame was not received, the switch discards it. So it's store and forward again. So no error checking on frames is performed by the switch before releasing the frame out of its port. So it's a great method to use to conserve bandwidth on your network. It's number 4. So store and forward. So the destination network interface card discards any incomplete frames using this frame forwarding method. So it's got a faster switching method, but may produce more errors in data integrity. Therefore, more bandwidth may be consumed. So it's got through again. So let's check it, and yeah, it's all correct. So let's proceed to the next one. Activity frame forwarding methods are instructions. Read the scenario based on the topology shown. Identify how the frames will be processed by dragging your answer to the appropriate fields provided in the table. All answers will not be used. So these are the terminology. So let's start. Cabling used in topology will be. This is the topology. So it will be a straight. To find where PC2 is located, PC1 will send out a blank data frame. And then PC2 will respond back to PC1 by sending back a message. So it's a unicast. If PC2 receives only half of the data in the frame, it will discard it. If PC2 receives many damaged frames on port 3, S1 likely will change back to blank switching. So store and forward. So let's check it. And yeah, that's correct. And yeah, we're done answering all the activities here in chapter 5. After answering those activities, we can get much deeper understanding about the chapter, especially about the Ethernet, like Ethernet frame field names, the MAC and LLC sublayers, frame forwarding methods, and many more about the Ethernet. So if you want to get familiarized to this chapter, just answer these activities again and again, and and also read it from first section to the last. So that's it. As it said in the introduction, this chapter really examines the characteristics and operation of the internet as it has evolved from a shared media, contention-based data communications technology to today's high bandwidth, full duplex technology. So that's all in chapter 5. Thanks for watching. Till next time.